Time for our final skill from Unit 1, using the intermediate value theorem and the mean value theorem. Number 27 says, use the IVT to discuss the existence of a solution, f of c equals 2, in the interval from 1 to 5 for this function. Then we'll address the second part of the question later. So let's begin. First, it's important to understand that we're looking for an x value that gives us a height or y value of 2. And 1 and 5 here are the intervals for that x value. So c must fall between 1 and 5. And if I were to plug in c, then the height or the y value should be 2. Well, the first thing we need to know to see if there is a y value of 2 is to figure out what these heights give us. So the first thing we'll do is find what f of 1 is. F of 1 equals 1 minus 3 times 1 minus 2. 1 minus 3 is negative 2. Minus 2 again is negative 4. And so, time for our second endpoint. F of 5 equals 5 squared, which is 25, minus 3 times 5, or 15, minus 2. 25 minus 15 is 10, minus 2 is 8. Now we are observing if 2, the y value 2, lies in between these points. So since 2 is between negative 4 and 8, then we can say using the IVT that there has to be some value c that gives us a y value of 2 because it's going to fall between these guys. So here's how the IVT works. We say, so just play along right now. I'll explain it in a moment using a graph and it'll make intuitive sense. But we begin, since f of x is, we always start this way, continuous over the closed interval from 1 to 5. And since f of 1 equals negative 4 and f of 5 equals 8, then by IVT, by the intermediate value theorem, there exists at least, so this is the key wording, at least one c in the closed interval from 1 to 5, such that, and this is where we're going to sandwich, say f of 1 equals negative 4. Then we write f of c equals 2, we know it's going to be in between, and then we finish with f of 5 equals 8. So we're comparing the y values, that's the key thing. So 2 is greater than negative 4, so it's going to go this way, and then 8 is greater than 2, so it's going to go this way. If it had been like 5, negative 3, and negative 10, then I would have gone the other direction, because negative 3 is less than 5, or 5 is greater than 3. So just pay attention to what direction you're doing the inequalities. And we're done. Okay, so that would be like part A. Part B says, go ahead now and find C. Find the C in the interval that makes that true. It's very basic algebra. Plug in C everywhere we see an X in the original equation and set that whole thing equal to 2. Let's solve this quadratic. I'm going to minus 2 on both sides. And then I'm factoring. So that's c minus 4, c plus 1 equals 0. So I get two answers for c. C could equal positive 4, or c could equal negative 1. But only one of these lies inside the interval, so it's always important to go back and check. They're asking for a c between 1 and 5. Negative 1 is outside of that interval, so our only answer is c equals 4. Now I want to discuss just in general what the IVT and MVT look like and what's the difference between them, when to use which. So looking at the IVT, by the way, this is a good time to pause the video and copy these notes down into your book. So the IVT deals with values. As you saw, if we were given f of x, the IVT might ask us to find a c such that the y value is 2 or something like that. or it could be f of c equals -3 or something like that. Whereas the MVT, so whereas the IVT deals with values, the MVT deals with slopes. So if they give us f of x, they might ask us to find where the slope equals 2 or where the slope equals -3. So whenever we're dealing with slopes, given f and we're going to f prime, that's when we use the MVT. And the way I remember this is M stands for slope. So we'll come back to that in just a second, but please know the difference when to use which. Okay, now here's what the IVT says in very simple, intuitive language. If we know that our function is continuous, so there's no breaks in the graph, no holes, no asymptotes, no jumps, nothing, then if we can verify that f of c is between the two y values, then we know that there is a corresponding x value, or c value in this case, that has to be between a and b. So it's imperative that you check that this y value, in the problem above, they gave us 2, and we checked that it was indeed between f of b and f of a. That's why we did this step. We had to find the y values ourselves and check that 2 was in between them. And if we can show that, and we know this is continuous, then there has to be some c between a and b. That makes f of c equal the value we're looking for. Now let's say the graph was not continuous. And let's say we're looking for f of c that equals 3. That's 1, 2. Even though f of c lies between f of a, which is like 1.7, and f of b, only 6, we cannot guarantee that there is some value, some x value that gives us a height of 3 because there's a break in the graph. So it has to be continuous for IVT to work. Similarly, that's the same for MVT. Notice that that's the same. We start with the same wording. Since f of x is continuous. Since f of x is continuous. Now, because with IVT we're dealing with values, the second condition has to be about the y values. But for MVT we're dealing with slopes, so the second condition has to be about slopes. We have to be able to take the derivative or find the slope at any value. So for MVT, we're continuous over the closed and differentiable over the open. I remember this order by C.C. Dew. Continuous over closed, differentiable over the open interval. By open, I mean parentheses here. Then we say there exists at least one c in the interval such that m sec equals m tan. And here's what we're saying with that. If there is some slope, we call this m sec, the slope of the secant line, which is just rise over run, then we know that there is some value in between where the slope of the tangent line, in this case it looks like it might be right here, is the same as the slope of the secant line. So it's not good. The slope of the tangent line, C is not going to be here because see it's too steep. The slopes, this slope and this slope are not the same. But we know that somewhere in between A and B there is a point. In this case it looks like C is right around there, such that m sec equals m tan. Now the way we say m tan in calculus is f prime of c, right? The slope of the graph at that point. So once you write m sec equals m tan, you then have to actually show the math. So this is part of the work. On the left side you have m sec, your old school slope. On the right side you have m tan, which is the derivative at c. So the way you would do this, so let's say they gave us f of x equals x squared minus 3x minus 2. The way you would find f prime of c is first find f prime of x. And then next step, you would plug in c. And that would be your right-hand side. You know that you've done it correctly because these will equal each other when you work out both. So let's do a problem where we see both IVT and the MVT. Number 29 says, the rate at which people enter a convention hall is modeled by the differentiable function. That's one of our conditions, R of t. The question says, explain why there's a time t. So usually they'll say c, but this time they're saying t, no big deal. Why there's a time t in this interval such that the rate of people entering the hall is 90 people per minute. So immediately you might be thinking, ooh, people per minute, that sounds like slope language. So your mind might go to the MVT because it deals with slopes. But I want to caution you. See how they're giving us R of t is already measured in people per minute? So we just want to know, so we're not actually taking the slope of the function that's given. We're just finding where R of t has to equal 90. No slope involved. They're giving me a rate, but I'm finding just the value. So I want to know where R of t has to equal 90 between 5 and 15, somewhere between 5 minutes and 15 minutes. Well, I can already see that 90 does indeed fall between being 100 people per minute and 55 people per minute. So I know that MVT, or rather IVT, is going to work. So let's set up IVT. Oops, I made a mistake. I'm dealing with the IVT, but I wrote down the condition related to the MVT. So I'm going to go back, rewrite it. The Y values. Since they said find a time t, I'm going to respectfully use the same variable. And now it's time to sandwich. Oh, whoops. I should use R. And I know that 90 does fall between the two. And looking at the numbers, 100 is greater than 90 and 90 is greater than 55. You need these numbers. 90, whatever you're looking for, must be between these numbers. Otherwise, IVT doesn't work. And we're done. Not bad at all. Let's move on to part B. Now, part B is saying, explain why there's a time t in the same interval such that the rate of people entering the hall is, keyword, decreasing at a rate of 4.5 people per minute squared. So, now it gets interesting. R of t is people per minute, but they're saying we're finding people per minute squared. So if R of t is people per minute, then R prime of t would be measured in people per minute squared. We are now dealing with the derivative. We are now dealing with the slope, meaning that MVT is the relevant theorem here, because we're dealing with the slope. So what we're basically being asked to find is find the time t where the slope is 4.5. But actually not even that is correct, because it says where the rate is decreasing at a rate of 4.5. So this should actually be negative slope. So let's get started with the MVT, which starts the same way as IVT, same wording. And now the second condition should be related to slopes, since we're doing the MVT, and that's where we talk about differentiability. I know that it's differentiable because they told me so. Oh, by the way, I know it's continuous because it can't be differentiable if it's not continuous. So then by MVT, there exists at least one time t in the interval 5 to 15 such that m sec equals m tan. Now we need to prove m sec equals m tan by plugging in values. So m sec is the regular old slope, rise over run. So we'll use r of 15 minus r of 5 over 15 minus 5. Equaling m tan, which is r prime of t. Well, what is r of 15? We'll look back at the table. R of 15 is 55, and r of 5 is 100. So r of 15 was 55, r of 5 was 100, over 15 minus 5. That would be negative 45 over 10, which is negative 4.5. And they said, prove that there is a point where r prime of t equals negative 4.5, and indeed, we have shown that. So let's do one last question. I want you to pause the video and decide whether this is an IVT or an MVT question, and then decide during what time interval must the height of the tree be between 5 meters. So pick the two closest times that you know the tree reached a height of 5 meters in between. So translating this question using mathematical notation, when must the height be 5 meters? We're basically saying where is h of t equal to 5 meters. Notice not only do the units match up, but this is given to be height. So we know we're dealing with a value and not the slope. Therefore, we're using the IVT for this problem. Also, I know that the height of the tree will reach 5 somewhere between it being 2 meters tall and 6 meters tall. So it will reach 5 meters in height somewhere in between here, meaning between 3 and 5 years. So let's use that interval to write our IVT statement. Just added on this last AKA for context because it's more understandable in English, but you would be fine with just this. Also, notice I used t instead of c, and that's okay. You can use any variable, but because these are measured in times, I decided to go ahead with that.